The first topic we'll show you today is all about bisectors, medians, and altitudes of triangles. We chose this topic as our important topic because the terms are good to know for the rest of geometry and future math classes. First, let's talk about perpendicular bisectors, which are line segments that are perpendicular to and bisect another segment. The segment property states that segments are equidistant from the segment endpoints. Its point of concurrency is the circumcenter, whose property states that it is equidistant from the vertices of the triangle. Next, we have angle bisectors. The segment property states that the segment is equidistant to the sides of a triangle. The point of concurrency is the incenter, which is equidistant to the sides of the triangle, as stated in its concurrency property. Now let's talk about medians, which are segments with endpoints being a vertex of a triangle and the midpoint of the opposite side. Medians don't have a segment property, but they do have a point of concurrency, which is the centroid. Its concurrency property states that the segment divides into thirds, the part from the vertex to the centroid being twice the size of the part from the centroid to the midpoint. Lastly, we have altitudes, which is a segment that is perpendicular to and spans from a vertex to the line containing the opposite side. The point of concurrency is the orthocenter, which has no concurrency property. The next topic is indirect proofs, which we chose as our difficult topic because they require a different way of thinking. Indirect proofs are paragraph proofs that prove the opposite idea does not work. The first step is to identify the proof in the statement if it's not already written. Next, assume the contradiction of the proof and always start with the word assume. Follow the line of reasoning until you reach a contradiction in the given, a definition, postulate, or theorem. Lastly, write a closing sentence using the wording on the screen.
Let's do a practice proof. The given is angle 4 is the exterior angle of triangle ABC. We have to prove that the measure of angle 4 is greater than the measure of angle 2. This is our diagram. So we will start by assuming the opposite of the proof. Assume the measure of angle 4 is equal to the measure of angle 2. In a problem like this, it is easier to set the two measures equal to each other because equal signs are more familiar and easier to work with. So the measure of angle 2 plus the measure of angle 3 equals the measure of angle 4 because of the exterior angle theorem. The measure of angle 4 plus the measure of angle 3 equals measure of angle 4 because of the substitution property. This means that the measure of angle 3 has to equal 0. This is a nonsense statement. So this leads to a contradiction in the definition of an angle. Therefore, the measure of angle 4 is greater than the measure of angle 2.
The last topic we'll cover today is finding the range of values for the missing side of a triangle using the triangle inequality theorem. We chose this topic because it's handy when solving triangles and doing proofs. It states that two sides of a triangle added up must be greater than the third side.
Two sides of a triangle are 7 and 15. The missing side is x. According to the triangle inequality theorem, 7 plus 15 has to be greater than the measure of x. So we need to find the range of possible values for x. Start by making all possible combinations of inequalities. Now solve these. These are all the possible combinations of inequalities. We can automatically rule out the negative 8 because sides of a triangle can't be negative according to the definition of a segment. So, 8 is less than x, which is less than 22. And the range of x is between 8 and 22.